Part 3 of 5.7 inverse of a function notes. This is the last part. Just a reminder, Tuesday we will be testing over chapter 5. Tomorrow we'll get the review. Monday we'll review. Tuesday we'll test. Any questions about that?
Is this the last part?
This is the last part. We'll get the review tomorrow. So let's move into the last part of 5.7. If it'll pop up on the smartboard. There we go. Verifying functions are inverses. So there's this method we can use just to verify that two things are inverses of each other. So it says let f and g be inverse functions. If f of a equals b, then g of b equals a. And that makes sense because what happens to our inputs and outputs when we take the inverse? They switch. So right here, a is the input, b is the output. So when we take the inverse, b becomes the input, a becomes the output. Does that make sense? Okay? So in general, f of g of x equals x, and g of f of x equals x. So we're kind of tying in 5.6 with our notes for today. So like I said, we're tying in 5.6, our composition functions, into our inverse functions. So if I take f of g of x, it should equal x. If I take g of f of x, it should also equal x. If they both equal x, then I know they're inverses. If one or both of them do not equal x, then I know they're not inverses of each other. Any questions on that? Can I move on to my example? So example 6. Verify that f of x equals 3x minus 1 and g of x equals x plus 1 over 3 are inverse functions. It wants me to verify that those two functions are inverse functions. So what do I need to do to verify that? I need to find what and what. What are those bottom two things? How would I read that left one? F of g of x. So let's find f of g of x of example 6. So let's find f of g of x. What does g of x equal? X plus 1 over 3. So I'm essentially finding f of x plus 1 over 3 because I can replace that g of x with that expression. Does everyone see that? So in my f function, what am I replacing with x? What am I replacing x with? X plus 1 over 3. So I get 3 times x plus 1 over 3 minus 1. I just took the x out, replaced it with x plus 1 over 3. Any questions there? What's going to happen with my 3's? They're going to cancel out because 3 is over 1, so I can cancel out diagonally. So that leaves me with x plus 1 minus 1. And what happens to my 1's? They cancel out also because 1 minus 1 is 0. So what do I get? X. Is that what I want? Yes, it is. I want it to equal x. Now what do I need to find? G of f of x. What does f of x equal? 3x minus 1, so I can replace my f of x with 3x minus 1. So now I'm essentially finding g of 3x minus 1. So in my g function, what am I replacing x with? 3x minus 1. I'm taking the x out, and the x out, replacing it with 3x minus 1. So I get 3x minus 1 plus 1 all over 3. What happens to my 1's up top? They cancel out. Negative 1 plus 1 gives me 0. So I get 3x over 3. What happens to my 3's? They cancel out and I'm left with x. Is that what I want? So, since f of g of x equals x and g of f of x equals x, what can I confirm about these two functions? They're not equal. They're inverses of each other. So I can just say they are inverses. If either one of my f of g of x or g of f of x did not equal x, then I would say they are not inverses of each other. Everyone good with that? Can I move on to our next concept? Our last concept. Solving real-life problems. In many real-life problems, formulas contain meaningful variables, such as the radius r in the formula for the surface area S of a sphere. S equals 4 pi r squared. So in those types of formulas, they have a specific meaning, right? Like it says here, r stands for the radius, S stands for the surface area of a sphere. In this situation, switching the variables to find the inverse would create confusion by switching the meaning of S and R. That'd be pretty confusing if I switched S and R, said S now equals R now equals S. That would just get really confusing. We can still find the inverse. So when you're finding the inverse, solve for R without switching the variables. We can just go ahead and keep the variables where they are, and then solve for that other variable. And that would be me finding my inverse. Does everyone understand that? So I wouldn't have to switch S and R in this case, and then solve. I could just solve for R. Any questions on that? So let's look at an example involving this equation. Find the inverse of the function that represents the surface area of a sphere, S equals 4 pi r squared. Then find the radius of a sphere that has a surface area of 100 pi square feet. So I have my surface area formula. How did it tell me to find the inverse on the previous slide? Do what? Just solve for r, right? Do I need to switch the variables? No. Nope. It tells me not to switch the variables and just solve for r. So let's solve for r. What would be my first step to get r by itself? Do what? Division divided by what? Pi and 4. So 4 pi. Because the pi's would eliminate and the 4's would eliminate. Whatever I do to one side, I have to do to the other. So S over 4 pi equals r squared. Any questions on that? First step. How would I get r by itself now? How would I get rid of the squared with it? Take the square root of both sides. So r equals plus or minus square root of S over 4 pi. So now I have r by itself, correct? Let me ask you a question. What does the r stand for? Radius. Can my radius ever be negative? No. Radius is a measurement We don't have negative measurements, do we? So do I need that plus or minus sign? No, because my radius is always going to be a positive number. So this is my inverse. Any questions on that? Now, it wants me to find the radius of a sphere that has a surface area of 100 pi square feet. So how can I find that radius?
R equal 100 pi.
Plug in 100 pi for S. It's telling me to find the radius of a sphere that has a surface area of 100 pi. Well, S represents surface area, so I can replace that S with 100 pi. Any confusion on what I've done? What happens to my pi's? They cancel out. What's 100 divided by 4?
25.
25. What is the square root of 25? 5. So the radius of a sphere that has a surface area of 100 pi square feet is 5 what? What's my unit? Not square feet. Just feet. So there's my radius. Any questions on example 7? That one wasn't too bad, was it? Questions before I move on? Here we go. Here's our assignment. Pages 290 through 291. Numbers 47 through 59 all. This will be due Monday, May 10th on campus, since we won't be in school on Friday. Pages 290 through 291, numbers 47 through 59 all. Due Monday, May 10th on campus. Any questions before I end my recording? All right.